right, I think we're ready to go. I've got 340, so we're going to get started. Hopefully you're here to hear something about Containerd. This is the maintainers track, so in this room all the CNCF projects get a chance to do an intro and then a deep dive. There's only two names up here, and actually it might be a bait and switch. If you're looking at your schedule, you thought you'd see Derek McGowan from Docker up here. Derek's here on the front row. He and I will do the deep dive tomorrow afternoon. So if you feel cheated, come back for the deep dive. But this is like a Containerd family project. We have several of the maintainers down here. Mike Brown's going to take the second half of this talk and talk through the CRI plugin. Akahiro's here. He's not speaking, but he's one of our maintainers. And Stephen Day is here as well. So if you don't get what you wanted out of the talk, we're all here. We'd be happy to talk to you. But we're going to jump in and take you through Containerd. And again, today, more of an intro. We'll stay a little bit higher level. And then tomorrow, also, I think it's also at 340. So again, 340 tomorrow is the deep dive. So let's get started. A little bit of history. Who came here and has never heard of Containerd? All right, just a very few hands. So Containerd started life in 2016, just after the OCI had been formed in 2015. Run-C was this default implementation. And so Containerd was created within the Docker community, specifically Michael Crosby, one of our maintainers, created Containerd as this simple kind of runtime manager over Run-C processes. So in Docker 1.11, you now had Containerd running, and you could actually restart the Docker engine, and your containers didn't have to stop. Containerd would manage those processes that were being executed through OCI's Run-C. So that was the very start. Again, in that same year, Kubernetes trying to both handle Docker as a runtime, but also Rocket, which was available at the time, created this abstraction called the CRI, the Container Runtime Interface. So that happened later in 2016. It was really late 2016 and then early 2017 that Containerd was promised to be contributed. It was given to the CNCF officially in March of 2017. And it was really this goal of not just being this Run-C manager for the Docker engine, but to be a complete sort of core container runtime that supported the OCI image format, that used the OCI runtime, and that would implement the CRI, so it was useful for Kubernetes as well. And at that time, we also added a plugin architecture that we'll talk about a little bit more. So fast forward to late last year, around KubeCon in Austin last November, I believe, we released Containerd 1.0. At that time, we also stabilized the API, and again, in the same kind of time frame, the CRI implementation had an alpha release. And so that's where we were last KubeCon North America. Since then, earlier this year, we did a 1.1 release. CRI continued to progress and had a beta release. But more importantly, we talked to the CRI plugin team. That was folks at Google, folks at IBM. Mike Brown here was part of that. We said, why don't we just have a single project? The CRI plugin can come into the Containerd GitHub project. We can work on it together and integrate those projects. So Containerd 1.1 was the culmination of that work. In that release, you actually had the CRI plugin within Containerd. And we'll talk again about how that looks architecturally. As the year has progressed, we did a 1.2 release just a few months ago. We stabilized the shim API, so now you have other runtimes other than just Run-C. So if you've heard of gvisor, Kata containers, maybe you recently heard about AWS's Firecracker project, they're all able to use this runtime pluggability within Containerd so that you can use Containerd from a higher layer but drive different runtimes underneath. And so again, a lot of that work went into 1.2, as well as, I don't think we listed it here, but The Microsoft folks got a lot of the Windows support into Containerd 1.2 as well. And as we have from the beginning, have had a significant focus on stability. So lots of testing and lots of eyes on the code and using it in different use cases. And that's also led to more extensibility, which we'll talk about as well. So a little bit about the why. I just kind of walked you through all that history. Docker, which again, many of you, if you're using Kubernetes, you continue to use the Docker engine as the runtime underneath your Kubernetes cluster. But over time, the entire Docker project and the engine, that scope has increased, and Docker does way more things than maybe you need underneath your Kubernetes cluster. And again, certain use cases, certain models wanted a runtime that had smaller footprint, or even replace certain capabilities that Docker provided in-house. So, out of that really came this idea of a common runtime. Containerd could be valuable to the Kubernetes community. It could continue to be valuable as a core runtime underneath the Docker engine. And now we have use cases from Alibaba has the Pouch Container Runtime, which uses Containerd. The Cloud Foundry Garden engine has been written around runc with their own management code. They're also moving to Containerd. And so again, this idea of just a core runtime that just supported OCI image, OCI runtime spec, could be used by many, many use cases. It's just a common core runtime. And then for cloud providers, we'll talk through adopters of Containerd in a few minutes. But allowing cloud providers to have a simpler runtime, less opinionated than the full Docker engine, more extensible, so that they could use it within their cloud environments. So today, IBM Cloud and GKE both have the option to use Containerd, and obviously as that's tested and stabilizes, you can expect that'll be the default at some point in the near future. As I said, in March of 2017, Containerd was contributed to the CNCF. And so, again, the parentage of the project, that's obviously been important for certain folks who didn't want to see a single vendor point of control around the common runtime they wanted to use. And then, like I've said, OCI image spec, runtime spec compliance, that would be a focus of Containerd as well. I'm going to not read every word on this slide because, again, when we get into the deep dive, if you come back tomorrow, we'll talk a lot more about these components. But again, there were a set of design principles that as we came to expand Containerd from that initial manager of runc to a more complete container runtime, extensibility, having loosely coupled components that could be used separately or together, and we'll see how that works. Having stable APIs, we have a very clear support policy on within the Containerd project. You can clearly see, there's no breaking API changes between point releases. All that's very clearly stated with clear end dates for support. And then unopinionated. So the fact that there are definitely defaults within Containerd, but they're all possibly can be overwritten, and each plugin gets to define their own configuration. And then we have a Go client library that allows you to basically bring all these disparate components together in sort of a common way, which you can use that or you can write directly to the services. So that's kind of where we started, and this gives you not too busy of a picture, but kind of a complete picture of that architecture. And I'm going to walk through just in the next 5 minutes a few of the highlights. But again, I want to reiterate that tomorrow we'll have more time to kind of dig down into these components. So again, you can see that there's a set of services. There's that client API with users above it, like Kubernetes, like Docker, like Pouch or other runtimes. And then there's those common services that then drive a set of runtimes, whether we're talking about runc, kata containers, run HCS on Windows, and then the snapshotters, which I'll talk about in a minute as well. So again, we have a Go client library. Probably one of the most positive things we continue to hear around Containerd is how great this library is to use, how easy it is to compose on top of Containerd using the Go library interface. It's sort of a smart or a heavy client in that a lot of the functionality is implemented at that level. So unlike the Docker engine, where push and pull are something that you ask the engine to do on your behalf, push and pull are implemented here within the Go client library. You do within this library have access to those low-level resources like snapshots, and really the main goal, of course, is to get a container running, and that means that the main job of the library is to put together that OCI configuration with your specific, if you're calling it via API, what program are we going to run? How are we setting up the namespaces? All the knobs and switches that the OCI config gives you. And so again, we're passing that through to run C. We don't have an intermediate representation, so that means if new features come about in run C, then we don't have to modify Containerd to handle those new capabilities. You can simply pass through an entire OCI spec if you'd like. Again, if you weren't writing in Go or you didn't want to interact with the client library, all of the services in Containerd are available over GRPC interfaces, and it mirrors those internal interfaces of each of the components. So things like snapshots, which if you know the Docker engine, if you know what graph drivers are, the backends of overlay or AUFS in Containerd, we call those snapshotters. So again, the high-level components, snapshots, content, which is the blobs, like from an image, the manifest, the layers, and then containers themselves, and tasks, which are obviously the PIDs, the actual process running within a container, and then an entire event structure around that. So, start container, stop container, eventing. Metrics are exposed through Prometheus. You can get metrics about Containerd itself, and also you get container level metrics from this endpoint, so you can simply enable that in the Containerd config and have access to metrics. As I said, we have the CRI plugin, which is now part of the Containerd GitHub project. Obviously Kubernetes defines the CRI API for a specific level. Obviously the CRI has been changing over time, so the CRI plugin supports a specific versioned CRI API, and then it simply uses that Go client library that I talked about to call into Containerd and do those operations. So your workload gets scheduled to a node, the kubelet wants to start a pod, that calls into the CRI API, which will then call into Containerd to actually start containers, and Mike will show that in more detail in a few minutes. As I said, Containerd, we focused on extensibility, being able to have plugins, and obviously one of the most interesting plugins that exists today is the CRI itself, the CRI implementation within Containerd. That is a plugin. It is built into Containerd's binary by default. So again, it's not a separate process that calls over gRPC, but it listens for the CRI API and then calls into Containerd. We have built-in snapshotter plugins for overlay, Btrfs, and AUFS. We have some other out-of-tree implementations. I think we have ZFS today. And you can actually do custom plugins as well. And so one interesting thing that the AWS Firecracker team has done is written a proxy plugin of their own to write their own snapshotter for their own file system use. I also mentioned runtime plugins, and so this is obviously interesting to those who want to do some other kind of containerization other than what Run C provides, for example, using the standard Linux C groups and namespaces. So you can write your own shim. And again, as I mentioned in Containerd 1.2, that API has been clarified and solidified, and we have people like the Kata team and others who have been happy with that API and found it to be useful for their use cases. And we also have a CTR install command where you can actually add these runtime plugins on the fly to your Containerd installation. So again, a lot of our recent work has been focused around this extensibility. You can do interesting things like have your own resolver interface. So if you have a custom pull flow with a registry, again, because you're in this Go client library context, you have direct access to the rest of the Containerd interfaces. Mike's going to talk about CRI, but again, the plugin model is very, very flexible in that you can self-register a plugin to do whatever you want it to do, and even have custom GRPC services that way. So again, I think at this point, a lot of people are finding Containerd to have all those core features that you'd like in a runtime, but also be extremely flexible. So based on that, here's a few use cases where we see people using Containerd today. Obviously, we've talked about Kubernetes and Docker. I mentioned Alibaba's Pouch Container, which is actually an open source project you can go look at on GitHub. They are using Containerd. I just mentioned AWS Firecracker, who implemented their own snapshotter and runtime shim for their Firecracker VMM project. There's a couple IoT use cases, Belina and Elliot, using Containerd in the IoT space. I mentioned the Garden runtime underneath Cloud Foundry using Containerd. Again, Kata, another VM-based isolation runtime. A couple other projects, LinuxKit from Docker, the Moby project, uses Containerd to run its services. Rancher has a project on GitHub using Containerd. And then I mentioned the two public clouds, IBM Cloud and GKE. Both have Containerd available in clusters that you can deploy today in their public clouds. And IBM also has Containerd in tech preview in our private on-prem cloud. Also, Azure has it in their ACS Engine open source cluster deployer, and I believe at some point AKS will also be potentially moving to Containerd. So again, and if you have ever followed Kelsey's Kubernetes the hard way, that also uses Containerd as the kubelet runtime. So again, in the last year, we've seen a lot of interesting uptake in interest in Containerd, a lot of use cases, and so we're happy with the feedback we've gotten. And of course, if anyone has further use cases where you're finding some aspect of Containerd doesn't work in your use case, we'd love to hear about it. But this is kind of an easy transition point to Mike to talk a little more about the CRI and how that's implemented.
Thanks, Phil. How's everybody doing after lunch? Everybody tired? Pretty good? Huh? So I'm Mike Brown. I've been with IBM for a long time. I left and came back again to work on open source. Like OS2 programmer, DOS programmer, pretty much done everything from telecom servers to session management and set operating systems. So when they said, Mike, you want to work on Docker? I said, yeah, that sounds like fun. Right? So I've been working on open source projects for a while. Then about a year and a half ago, 2 years ago, they said, how about Containerd? We need a shim to hook up between kubelet and Containerd. I don't know if you know today, there's a Docker shim that's using the CRI interface. That's how you get containers today by default. Well, now if you want, you can change the defaults to use Containerd as long as it's installed and running, and it works pretty good. We test everything that gets tested for Docker as well on Containerd. On every PR that we push, we're doing millions of tests, and it actually runs with less flakes, we think, no offense, than Docker that does. It seems to be pretty clean. Okay, and it runs a little faster. It's a little smaller, and I think that's one of the points to why we did Containerd, because the Kubernetes guys, they were a little disappointed with every time Docker came out, there wasn't a lot of talk about how it was going to affect Kubernetes. Okay, so when the CRI interface came out, it was, okay, we're going to have a very official API, and if you implement these services correctly, we'll test for it, and containers slipped in that slot. Okay, so you see this little box here called Kubelet. As Phil mentioned earlier, we have a GRPC API. We have a daemon that runs, that receives the requests. We have registered through the GRPC that we're going to service the CRI API. We typically only talk to Kubelet unless you're using one of the tools like crictl. crictl will be another customer of this GRPC API. You can create a pod with it or just inspect. Usually just inspect, because if you create a pod with some other tool besides Kubelet, then it's not going to tell the rest of the cluster what's going on. So that's sort of an interesting point. Let's see. As we're showing here, every time on the right, every time we create a pod, we create a place where we put the resources, and that's going to be in a namespace. So pod in its own right is really just a logical concept. We call it a pod sandbox. And what we'll do is create one additional container just for that pod, so that when it exits, we get a final result from the pod. And also so we can host the network namespace for all the containers in the pod as configured by your YAML, right, for the pod. We use, as shown, we use CNI to do all of our networking. After we create the pod, we'll go ahead and create a namespace for it, a network namespace, and we'll use the CNI plugins to execute your however you've configured it, be it flannel or whatever, weave. They're all supported. As shown, we're using run C as our default runtime, but there's a new way to configure per pod the ability to switch runtimes to kata containers or some other runtime. So it's just a new little spec. So you can say, I want this pod to be defaults, or I want it to be a VM or whatever. Okay. A little more detail on the CNI integration. Again, all the plugins are supported. I've got a PR I just pushed last weekend where if you do an inspect on the pod, you'll actually get the CNI results. If there's some kind of error in your configuration of CNI, we're going to be showing you that result as well. And we show where the config paths were for all that kind of stuff. So another thing you're going to get from Containerd is a little more help in the debug area. Is my network working? That kind of stuff. We're going to try to work with those guys and make sure that's all working well. These are a set of the CRI services that we support. We support them all. One of the interesting ones on here is that we create your streams for standard I/O that goes from the containers you launch all the way back up through API server and then subsequently to Coopctl. Okay, so if you've attached, right. See that? There are two tools in use. You've got CTR and crictl, or crictl, whatever you want to name these things. The CTR tool ships with Containerd, and the crictl tool is it used to be Incubator, and now it's moved over to some other repo. So you can also help on that tool if you want. crictl, it's the other side of CRI for debugging and analyzing what CRI container runtime integrations have built. We actually have test cases that are written in the crictl repo, a whole bunch of cry tests. So it's sort of interesting to if you want to help on debugging or writing test cases. It's a little easier to write the test cases that go here in CRI than it is to do the end-to-end tests in Kubernetes. Okay, and it's focused just on the CRI side. In my particular host here, just running on my laptop, I'm just using kubeadm. But again, you could use just about anything like Kubernetes the hard way to launch. I guess we'll bring up a little demo. Probably an eye chart. Okay. So on this particular host, again, it's just a virtual machine, VirtualBox. Any VM or any host will work fine running Ubuntu. And showing here how we launched it. Somebody was asking earlier, how do you configure kubeadm to use? Well, there's some parameters over here in. Let's see, that's the default. That's our default kubelet. You can configure your XRR. You basically just tell kubelet that you're going to want to run a remote runtime, whatever kind of timeout you want, and where the sock is. And this is the default sock that we use for communicating over GRPC. Okay. Anybody have any questions so far? I think we're good. Okay. So let's see what we got here. So as you can see with on Coopctl, we have one pod. So wide. It's currently running in Nginx. It runs pretty quick, but for the demo purposes, I just want to make sure everything's already up and running. So this is the Coopctl command for taking a look at what pod we currently have running. Let's look a little bit deeper using crictl. And here we're showing not just that pod, but also the pods that were created for the cluster, as well as the networking, which is flannel in this case. Okay. And if we want to get a little more information on it, we could look at some of these pods, like doing an inspect. 485. Put that to less. And you can see some details about the pod itself. For example, what the IP address is. We might need that later. I mentioned before that we create a pause container, and this is going to show the details for that as well. If you're familiar with OCI specification, we support OCI specs, both the runtime and the image specs, and this is a runtime spec for a pause container. All right, showing the command, the arguments to the command. Caps, you can see what security permission. These are the default security permissions that Docker uses. We use the same default security permissions in Containerd as Docker does. You'll find that we try to use all of the Docker defaults so that when your pods go from running on Docker to running on Containerd, they just work. Okay. You can modify the defaults if you want to be more secure or less secure, as well as you can in Docker. And we're showing the mounts that were set up. These mounts are in the OCI spec format, not in the Kubernetes format. Okay. So now we know the IP address, we can probably curl that guy. So Nginx is up. The inspect worked. It gave us the right IP address. We can also, I think, look at some logs for this guy. Let's see. There we go. I curled it earlier too, just to make sure it works. Okay. There's also, I mentioned I guess we could look at stats. Let's see here, sudo. Here's all the different commands we can get. Let's see, stats command. And you can also scope that to a pod or whatever. Let's see, what was that? What was that shortcut ID? Oh, this was Fox Charlie 6. Let's just see what he's up to. Nothing. I need a pod. So get pods. It's hard to remember the different command syntax. It's close. You can guess the different we tried to use the same commands between crictl and Docker. So if I want to do a ps all like Docker does, that also works here. If I just want to list containers. So I'm just trying to give you a feel for the tools. The tool set, but they're there and they're pretty easy, and we take issues and PRs to extend them, enhance them, make them better. Okay, let's see. So again, if we want to do stats on that particular pod, and we're back to 485. And I'll show you how long it took Nginx to get that. Those curls. Wasn't a whole lot of work to do. Okay. We also have the CDR command. This is the command I mentioned earlier that ships with containerd. They like to say it's an unsupported command. What it really means is it works, but we don't want this to be a Docker replacement API, command line tool. All right. Not meant to be, and the commands might change, the syntax might change. I can tell you a couple that moved, and we don't worry about them moving it much because we're not expecting anybody to write scripts to use when they're using these. Okay, if you want to use scripts and things like that, you use the Docker tools or some other higher level tool like Kubernetes where they support their APIs. I mentioned Docker just for a second. Let's see what we got going over here. So this is Docker running BusyBox. Well, it's using the same containerd. So like 3 weeks ago, I installed an update on Ubuntu, and it automatically updated the containerd that was on my computer. So what that really meant was Docker is using the same version of containerd that I was using in development. And everything just works. So we've got this concept of namespaces, container namespaces. It's not the same as a Kubernetes namespace or Linux namespaces, but you can actually have one tool using containerd like Docker, and it's going to have its own set of containers, and they're separate, isolated from Kubernetes containers in pods. Okay, so if I were to do a CTR namespaces, one of the commands, CTR, probably list, ls, sudo, thanks. the KDS.io is the default namespace that CRI uses, crictl containers, and Moby is the one that Docker is using. So you can list out within CTR the different containers by namespace by just specifying a -n. So if I say CTR -n Moby, and then container, and I believe it's ls, and I got a sudo again. At least I'm consistent. Yeah. Control 8? Thanks. Cool. I'll try that next time. I love coming to Linux conferences. Everybody gives me the hints.
I think
We're at time?
we're a minute over.
Okay.
All right, so I think I'm pretty sure we're out of time. I think we end at 4:15. We're a minute over, but if anyone has questions or other, there's a whole group of Containerd folks up here. We'd be happy to talk or even step outside. But thanks a lot. I don't think we have time for open questions, but we'd be happy to answer some. Thanks.